or two ago got the first round correct. Okay, so let's see. This. So just to give you an idea, right? Ones, tens, hundreds, thousands. Okay, that's millions, that's billions, that's trillions, that's gazillions. No, that's not the real word. You know what I mean? But you get the idea, yes? There are words for all these, but who cares, right? So this is a huge number, right? That's how many different brackets are possible. It's how many different brackets are possible. So even if, let's say that you wrote a computer program that would just sit there on a loop and just fill out random brackets, like do different brackets each time. And you just like set the program and you walked away, right? You're trying to beat the system. Each time you submit one of these, it's going to take a few seconds, right? I mean, so there's no way you're doing this. This is, how many people live on the planet? Anyone know the population of the planet right now? I don't know what it is. 8 billion? Okay, so what's 8 billion? 8 billion is, let's see, this is millions, billions. So let's take out those zeros. So what I'm doing is I'm dividing this by how many people there are, and it still puts us somewhere around this number. So it's like, to give you an idea of how big that number was, for us to guarantee a winner, every person on the planet would have to fill out 900 million different brackets. So I would have to fill out my 900 million that are all different from one another, and then you have to do it. Yours can't match mine, okay? And every person on the planet has to do that. And then we'll have a winner, guaranteed. Do y'all understand just how big that number is, right? Yeah. These powers of 2 to the 63, right? So take that piece of paper I folded once, twice. If I could fold it 63 times, if I could, then in theory I would have that number we had up here, which was this like astronomically large number, right? Okay, I just wanted to share that with you. Normally when I cover this, we're a little bit behind in this class, so normally I'm covering this and the tournament's actually going on at this time, but it's over. It's okay though. So powers of 2. All right, how are we doing on time? 10 minutes? I have one more example for you. One more example. It doesn't have to be powers of 2. Do you all know what a petri dish is?
Oh, yes.
What's a petri dish?
Something you put stuff in.
Petri dish in biology, right?
Yeah, sorry. Yeah, it's like a, I don't know why I described it like that, but yeah, it's like that.
A petri dish is a little like plastic or glass dish, and it's sterile, meaning there's nothing living in it. And then you take it and you open it, and then you just go like, take a swab of like the door handle or something with cotton, you just rub it in there, and then you close it. And then you come back in a few days and you realize there's all this stuff. You've never done that sort of thing? Or, yeah, don't touch the door handle. Well, but that's why we have immune systems as well, right? To protect ourselves from that. All right, so look, in a petri dish, let's say that we have this bacteria that's been studied. And what they've determined is that there's this bacteria which triples itself let's just say every 24 hours, so every day. Every day. So here's the idea. This is the day. This is the number of bacteria we have. At day 0, we put one little bacteria in there, one little guy. Okay? Put him in there. A day later, how many are there? 3. Okay? 3. So what happens is this. You have this little bacteria, right? Okay? And that's at day 0. 1 day later, it mutates out and kind of splits off and goes through some process. I'm not a biology person, so goes through some process, and now there are 3 of them, right? They don't have eyes, but just for fun, right? That's day 1, that's day 0. Okay, what about day 2? How many do we have now?
9.
We have 9. Not 6, right? It's 9, because this one now splits into 3. This one splits into 3. This one splits into 3. Right? What's that? What? That's, I just said there's some bacteria that triples every day. It's been studied, we know that, okay? It could be that it splits into 4 every day, or it could be that it does this every hour. It depends, every bacteria is different, right? So this is just to give you an example of just how fast this is gonna grow, right? What happens on the next day, 3rd day? Dun, dun, dun. How many do we have? 27 now, right? 27. How are we getting that? 3 there, 3 there, 3 there. You can't see their faces anymore, but they're not happy because it's getting kind of tight in there, right? There's a lot of them in there now.
Have some angry faces.
Angry faces, they're, right? That's what happens when you get too many things around each other. They just start, you get the idea. 27 of them there, right? And then the next day, 4 days later, 81 of them, okay? All of these are triple, so they're all powers of 3. They're all powers of 3. This is 3 to the first power. This is 3 times 3, right? 3 squared. This is 3 times 3 times 3. That's 3 to the third power. This is 3 times 3 times 3 times 3. That's 3 to the fourth power. So we have a function for this, don't we? The function is what? 3 raised to the x. 3 raised to the x. That is an exponential function of base 3. Exponential function of base 3. So let me put just a general definition here. Anyone want to tell me how many we would have after 10 days? You need your calculator, wouldn't you? Anyone do it? 3 to the 10th power? So bring your calculators next time. I don't want to see a bunch of people out here with their phones and stuff. I want to see calculators because you need to know how to use them. That when you get to the next test, you're not like, oh, I don't know how to use my calculator, right? Because we're going to be doing a lot of things on the calculator for the next few weeks. What was it, 59,000? So it grew pretty fast. Actually, what do you think grows faster, the 3 to the x or the 2 to the x? Which of those do you think grows faster? 3 to the x, because the 3 is bigger than 2, right? Okay, so in general, an exponential function of base A is f of x equals a raised to the x. You know how when we were talking about lines, we said lines are y equals m, or mx plus b, parabolas are ax squared plus bx plus c, polynomials looked a certain way in terms of the generic form. This is the generic form of an exponential function. We have some number raised to the x power, right? This is called a base A exponential function. There are 2 restrictions on what a can be. First, a has to be a positive number. You are not allowed to plug a negative number in there, okay? Right? And then the other condition is that the a can never be 1. And the reason it can't be 1 is because if we put a 1 there, what's 1 raised to any power? 1 raised to 1 or 1 squared, it's just going to be 1, right? So it's a very boring function, just stays 1 the whole time. So we just say, throw that out, let's not count that, it's too boring, right? So this is what we're going to do starting next class. What's today, Wednesday? So next week, we're going to graph these. When we graph these, we're going to say, oh my God, that's easy. It's going to be simple. All we're going to do is use our calculators. We're going to make a t-table, and we're just going to graph it real quick. What we're going to do after we learn how to graph it is we're going to say, where do we see these in the real world? So we're going to start dealing with simple interest formulas, like when you get a credit card, how they calculate how much interest you owe. There's formulas for it, and they involve exponential functions. So we're going to do that. All right? Okay, everyone, have a great weekend, right? Stay safe. The roads will be wet, I think, the next few days.
Sure, I have a question.
Yep.
Which one would I use for the power?
So for your calculator, okay, see that right there, y to the x? Let's try that. So go 2, and let's hit that button there, and then hit 3. So that was 2 raised to the third power. Let's do another one. Let's go 3, and then raise it to the third power again. That's 27.
Okay.
So that's like the caret key that I was showing. Okay?
Thank you.
Do you have any napkins?
Napkins, I only have wet wipes.
Can I use one of those?
Yeah, you can use that. It's nasty though.
It's okay. I just,
Oh, you spilled it there? I'll get it right here. I'll use this.
thank you.
Yep. Yeah, let me turn this off.